Hello, welcome everyone. Thank you all for joining us today. I'm really excited to be hosting the LocalStack Meetup, virtual meetup for the first time. My name is Brian Rinaldi. I lead developer relations here at LocalStack. I'm coming to you live from Orlando, Florida, where it looks nice and sunny, but it's actually pretty overcast. Our summers are full of intense rainstorms. But anyway, right now it's okay. Well, I really appreciate you all joining us. We've got a couple of great speakers coming up, and a lot of good information. So we're going to be talking about testing AWS database migrations and accelerating development with Cloud Pods. So those are the two talks we've got lined up from great speakers from here at LocalStack. But I also want to kind of share some information before we get started. Here's our agenda. We're going to do a little bit of intro and welcome, which is actually what you're in right now. And then we're going to have our first talk, which is going to be deploying test data migration pipeline and DMS and LocalStack with DMS and LocalStack. And then we are going to have a little bit of Q&A with our first speaker. And then we're going to have our second speaker, which is going to be talking about accelerating cloud development with Cloud Pods and LocalStack. Then we'll have some Q&A to follow that, and then we'll be done. So with that, I'm going to go ahead and ask you to go ahead and join us at slido.com. You can use that code that's on the screen right there, or you can QR code it right now. That's going to be able to give you the access to ask any kind of questions anonymously that you might have during this whole presentation. We invite your questions. That's kind of the point of this. We do this live so that you can ask questions and participate. So I hope that you will do that. Go ahead and go to slido.com and enter that code. I'm going to leave it up for just a second so that everybody has time to do this. I don't want to kind of move on to the next step until you're done. So, okay. I'm going to assume you got it. If not, we will put this information in the chat. So don't worry if you missed it on the slide, you will be able to get it there. Okay, so to introduce our speakers, so obviously I already introduced myself, but we've got Mathieu and Bart are both going to be speaking today. So we're going to welcome Mathieu, welcome Bart.
Hey, hello, Brian. So I'm joining you here from Alberta in Canada. As Brian mentioned, I will be talking about DMS. I joined LocalStack earlier this year, and I joined a team that was working on DMS. So really excited to talk to you about that.
Great.
All right. Hey, everybody. My name is Bart. I've also recently joined LocalStack this year. I'm a technical account manager looking after some of the accounts here at LocalStack. And I'll be talking about Cloud Pods and how can they accelerate your cloud development.
And what it doesn't show in your background there is you are joining from beautiful Barcelona, correct?
That's right.
Yeah, love Barcelona. I finally got to get a chance to go this year. Love that place. All right. So with that, we're going to just do a little bit more quick intro here because we just released 3.6 last week. So if you haven't had the chance to check that out, I really invite you to go ahead and do so. We've got a new CloudWatch V2 provider is now the default, which is going to give you more efficient metric storage and improve data integrity. Cloud Pods now support end-to-end encryption. EventBridge now supports archive and replay functionality for recovering from errors, validating workflows. Step functions have been enhanced with a bunch of features. You can apply custom tags to Lambda functions so you can get more predictable function URLs and so much more. You can find out more. They're going to be posting, hopefully, the link to the 3.6 release notes, which is shown here on screen on your on the comments, so you can just kind of click that and hopefully you go check that out. And we as always, we invite your feedback. We love feedback on everything we're doing. We build all this stuff out in the open, so we invite you, the community, kind of give us feedback. You can do so either via GitHub or you can join our Slack, which is a great, we have a great vibrant community going on Slack, so please do so. Okay, with that, we're going to introduce our first speaker. Mathieu, I'll let you take it away and tell us about deploying and testing data migration pipeline with DMS and LocalStack.
Perfect. Well, thank you, Brian. So we'll look at deploying and testing data migration pipeline with DMS. So let's jump right into it. So first, what is DMS? It stands for Database Migration Service. So we'll have a quick overview over the architecture. So basically, you need to have a source database and a target database. And the rest here, the infrastructure to be able to create that, you first have source and target endpoints. So that's where you have all of the configuration needed to be able to communicate with your source database. That it be the location or yes, so that it be the location or the credential. And we also need a replication instance. Replication instance is basically a EC2 that is executing your code. And the last thing is your replication task. And the replication task is basically where everything is happening. We'll get over that in detail in shortly. So as far as the source, I only listed a few here. There are quite a few more than that, but this is a general overview. So for Amazon hosted, you can see we have S3, we have the whole RDS, we have you have DocumentDB. For self-hosted and EC2, basically the self-hosted can also be on-premise. So yeah, you can see you got MongoDB, Postgres, MySQL, MariaDB, and a whole lot more. I would invite you to go to the AWS documentation if you are interested into learning more. And for third party, they also support migrating from Microsoft Azure or certain Google Cloud database. Yeah, so what is really important to know is for each database, there are usually some database-specific configuration. We'll get over MariaDB later in the demo, like just ways to configure the bin log so that DMS can have access to all the information needed to send your data. And so the source endpoint, as I mentioned earlier, this is where you keep your endpoint configuration, your credentials. So, you know, the URL and database and password and everything needed to be able to communicate to your database. As far as the target, there are a whole lot more than what we have here. I just put a few here that I felt were more important. And mainly there are two types of data migration for the target. Basically, you can either be homogeneous, which means there is no data transformation and you have a lot less control over what will be happening, but it will, and it will also be happen on serverless. It is kind of a fully managed, let's say if you want to go from Postgres to Postgres, then you can go from any Postgres into a Postgres in your RDS. Same thing, you could go from MongoDB to DocumentDB. And you have also a whole lot of non-homogeneous. And what is important to know for non-homogeneous is that there is still support for some on-premise or for some EC2 databases. But yeah, so for non-homogeneous too, it's not necessarily database per se. So you will have like Kinesis Stream, you have some caching services. So yeah, and you have a whole lot more of AWS services that are supported that can be used as a target. The replication instance, like I mentioned earlier, this runs on EC2, and as you configure your replication instance, this is where you will configure everything going from scaling, multi-AZ, how much memory it has, what's the size of the EC2 that you're using. So it really just configuring the bare bone of it. And then the replication task, in a sense, this is where everything happens. So you have like different, like all of your configuration will happen there. So you have two main type of replication tasks. You will have full load and CDC. Full load, basically, when you start a task, the goal is to go from everything that is in database A and move everything to your target database. CDC, you will not transfer everything that was already there when you start the task. It's a capture data change. So it will just bring the new changes as they get created. And there is also a third type that I didn't mention here, but it's basically a full load and CDC. So it will start by doing a full load and then it will keep going with the CDC. You can either have them managed. So basically you manage them on your replication instance, or it can be serverless, in which case you don't need to create a replication instance. And as soon as you start a task, AWS will create a serverless instance for you. This is also where you define which tables. You can define some schema transformation. There is a lot more configuration that goes in here. We'll go quickly over it during the demo. If we'd go over all of the feature of the replication task, we'd be here until tomorrow. So let's keep on moving. Yeah, so in the replication task, this is also where you manage the state of your task. If you start it, stop it, restart, all those fun things. And this is also where you have access to monitoring. So we'll look in the demo as well. We will go over some of the statistics that you get. So the amount of entries that were moved and how many tables were created and everything. So that's all coming from the replication task. So it does a couple of things. As far as what we have done for DMS, so this is a work in progress. We started that earlier this year. As I mentioned earlier, I joined the team that was already working on it. We have, so far, we can support sources for MariaDB and MySQL. We will support them, that they be created by RDS, part of the LocalStack instance, or if they're external. So I will demo, basically, I will have one in a separate Docker container that we will still be able to target. And as far as endpoints, we support Kinesis streams. And yeah, so we support full load, we support CDC. We do not support yet full load and CDC. And we do support table mappings, and there are a few more features that we support, but it is still a work in progress. And yeah, we have a full support for table statistics and task statistics. So, well, let's jump right into the demo. So you can see here, this is what we'll be spinning up. It's very similar to the one I showed at the beginning. We have on top here Secrets Manager. So this is where we'll be keeping our secrets. So the database, password, username, the URL, and everything will be kept on a Secrets Manager. And I have extra MariaDB that lives outside of AWS, outside of LocalStack, that will be basically defined in my Docker Compose here. As you can see, Docker Compose is pretty simple. We create a LocalStack container, and we will create also a MariaDB. So let's just go ahead and start that up. That should start. Oh, needs to pull a new image. Always scary for demo. Okay, we'll get this. So let's quickly have an overview of the stack as this is starting. So we can see we'll have a CDK stack that we'll be creating. Also, that demo is available in our samples. If you want, I'm pretty sure somebody will post that in the comment, and then you can run it by yourself. Yeah, so first we'll create a VPC and a security group to basically allow everything to communicate with one another. And we'll create a role that will be used. Yeah, I think perfect. We have everything started here. So we'll just start. Oh, let's not destroy anything. I will remember. Yeah, make start. Easy. Okay, so, oh no, not make start. Make deploy. Yeah. There's only 2 commands. I should remember them. Okay, so as CDK will create our stack on our instance here, I will keep going over our stack. It should take around a minute or so. On AWS, create that same stack. It takes somewhere in between 45 minutes and an hour. So this is one of the main advantage of working with LocalStack. So we can see here we're going to create our instance. The instance is pretty simple. It will just be a MariaDB instance. And as I mentioned earlier, there are some like database specific parameters that have been created. Here for MariaDB and for MySQL, this is simply just a bin log. There are a few information to enter to make sure that the bin log has all of the information we need to be able to recreate your database. As you might have mentioned too, I did not create a password and username. I will let basically a CDK create that for me. I just retrieve their secret so that I can use it later for the source endpoint. For my external database, that is just a MariaDB container. You can see here I'm creating a secret for it. So you always need, for MariaDB, or MySQL, you would need to add host, port, username, password, and the database name to your secret for DMS to be able to properly communicate with it. And then we'll go quickly over it so you can see we're going to create our two source endpoint. So we first create a role to our endpoint that will allow the endpoint to get the secret value for our secret. And then we create our endpoint with our secret ARN and our endpoint role. So yeah, same thing. We're going to create. So we create our two source endpoint and a simple Kinesis stream. Important to notice on the Kinesis stream is that we do need to apply a grant read write from DMS. So basically our role that DMS will assume later, we need to make sure that that Kinesis basically has a policy that will allow it to write to it. And next, our replication instance. The replication instance is pretty simple. We are creating a role. The role name is super important because we cannot attach a role to our instance. DMS will go and look for a role that is called DMS VPC role. And yet the rest is pretty simple. You can see we define if it is publicly accessible. We can define the security group and everything. Yeah. And then, yeah, so we're going to create 4 tasks, and that's what will go in the demo. Will be the 4 tasks here. We have a first one will be a CDC, so for change data change, and it will only exist. Will only take databases that starts with the letter A. Just to kind of show a little bit how those table mapping rules happen. Our second one will be a CDC task as well. And it will only include the table novels. And then we have 2 full load tasks. Same thing. The first one only databases that starts with A, and the second one only the novels table. So we'll go over to our stack. Yes, it took 41 seconds instead of 41 minutes. That makes me happy. And we can quickly look. Yeah, so we can look at our replication task. We can see we have the 4 replication tasks that I mentioned. There's not much to see here. We can see that they are ready and that they, so that is what we need for now. And next step is to run. So like the demo, I will first do a full load and then a CDC. And I will talk to you through a little bit each step along the way. So we can see here when we're starting the full load, we're creating, we're first dropping our table just to make sure that there was like nothing left in those in those databases. Then we're going to create a table, insert some data. As you saw, we added 1 author, we added 1 account to the accounts table, and we added 2 entries to the novels table. So now we'll start the full task 1. That takes around 15 to 20 minutes on AWS to do. I enjoy those couple seconds. So we can see we start the full load. It went from starting to stopped. So here we go. And now we are reviewing. We received 6 Kinesis events. So I'll go quickly here. We have the drop table, as I mentioned. So we'll have 2 drop table, 1 for accounts and 1 for author. Remember, novels is not here because we only filtered for A. And then quickly here, we got control here that should be, yes, we have another author create table. And then here we have our 2 entries that we added. So that first one here will be what we loaded into accounts and then what we loaded into authors. You can see all of our data here. So then for the second one, it will be very similar, but we're only going for novels. So as you can see, very similar, but we only have 4 events, which will be our drop table, create table, and then the 2 novels that we added. So we have all of the data here, and those are basically everything that we receive through Kinesis. So we can see here like all of our start replication task, and then we are describing we're getting our records. So that is everything we're getting from here. So that's it for the, we still have the table statistics. So quick overview over the table statistics. Basically for the task one, we can see we'll have like each table here. So the table statistics for each table. So that first one here, hard to read always, but you can see we loaded one row onto the table account, and here we loaded one row onto the table author. And then for the table statistic for the second task, we probably loaded 2 rows onto our novels table. And then second one, just to demo CDC. CDC will work a little bit differently, where what we will do is that we'll first create the table, and then as we start the task, it will first create the table. So we should see some create table happening when we start the task, and then nothing will happen. And then as we will later on basically run cursor, we'll seed some data into it, and we'll alter some table. Then we will like receive the Kinesis as it goes. So here we see we started, we created the table, and we have all of our tasks are running. So, well, that was fast. So that is the Kinesis events we received. We received 5. So basically from task 1 and task 2, both task 1 and task 2 create a first event that it basically creates a table called AWS DMS apply exception. That's something that happens on CDC for DMS to basically be able to manage its exception and control them. And then we will have our, as you can see, we have all of our table definition here so that we can recreate those table for all our tables. We have novels, authors, and accounts earlier. And then we can see now we're going to run the proceed and wait and grab our Kinesis again. So yeah, it happened. So you see we're expecting 4. It should be there. Woohoo, it happened. So it took a few seconds, but here we basically created all of those in our database, and then we waited to receive them in our Kinesis. And as you can see, we have our create author. We have a new entry in the table novels. We have another entry in the table novels. We have one more entry in our table authors, and one entry in our table accounts. So this is everything is accounted for. And then for the alter event, there's a lot of alter event. I'm just displaying 3 here just so that we can have a little bit of an understanding. So I'm going to alter the table authors to be a varchar. So it is a column type change event. We'll have a drop column event. So we alter table drop column profile picture, and we'll have a add column to our novels table. With basically is stuck. Sure, we have good names. And here we go. So let's fire that up. And yeah, it didn't take too long. Here we go. So we have our 3 events technically. Maybe we can make that screen a bit bigger. Will that help? A little bit. Okay. Yeah, so we can see we received our 3 events. So we have column email, old table def. So that allows us to have like everything that the table was before the change. We can see email here was a string of length 255, and the new table def email is a string of length 100. And then quickly here we have is stuck. Once again, we'll have is stuck here as nullable, and yeah, we can see it got add column to novels. And our last one, profile picture. If we go down, it got drop column in accounts. And then table statistics are fairly similar for CDC. We can see we don't have the full load rows that we had because it was not a full load. What we have is DDLs or apply DDLs. So that would be the drop column and those things. And then we have some apply insert. I didn't do any deletes and updates, but as soon as we would like modify element or delete or drop element from a table items, this is where it would go. And yeah, that sums it up for the demo. I hope it was helpful. I'll go, okay, what's next? So as I said, this is still a work in progress. So we currently have other engineers that are working on our serverless. So basically being able to do the same thing, but with serverless, so without having to create a replication instance. And we're also right now working on S3 sources. And as always, well, let us know if your company has more needs for different supports, that it be on different features of the service or added sources or endpoints, targets. And yeah, with that, let's go to a quick Q&A.
Thanks, Matthew. That was great. I particularly love this demo because it shows, number one, that how you can do something with LocalStack that normally would take a lot of iteration time over the course of like waiting for the deployment to happen to AWS, and you can work locally and do this much faster. Number one, and number two, because I'm going to be honest with you, database migrations scare the heck out of me entirely. So like the fact that you can just kind of run this all locally and do that without kind of messing with anything sitting even in a test environment. I get really antsy about database migrations because I think early in my career I made a mistake and wiped our whole database, but that was that was like 28 years ago. So but I think ever since then I've been scared this stuff. So being able to do that locally is super powerful.
Yeah, it's definitely good to have tools to help us with those.
Right.
Yeah.
So we do have a few questions. I'm going to go ahead and ask them. I think some of them you may or may not have answered during your presentation, but we'll revisit them. So the first question comes in, when will DMS be general available?
Yeah, so DMS is available for enterprise customer only. I do not know what is the plan to have it for general availability or not. Right now it is available for enterprise customer. Since it is still early in production, it is available only when we open when create the flag. Basically, there is a flag enable DMS here that needs to be added to environment in order for DMS to be available. As far as general availability, I am not necessarily the right person to answer that, but yeah, I know it is only enterprise feature right now.
Okay, makes sense. So enterprise feature, and you probably like to get that flag turned on. You have to put if you're an enterprise customer, I'm assuming you have to put in a request to whoever your sales rep or to get that turned on our end. Is that the process they would need to go
No,
through?
it's if you have as soon as you have enterprise
Oh, you can
authentication
turn it on
token,
yourself.
yeah, you can turn it on. It's just an extra, just
Okay.
just a flag you add to your LocalStack instance.
To your LocalStack instance. Okay, makes sense. Totally. Okay. Next question. This I think you answered at the end there. We are working on serverless. Is that what?
Yes,
That's what you
we're
said, right?
actively working on it.
Okay.
Yeah, so
Hey.
it will be there soon. Keep up with latest, but yeah, no, and the progress is going pretty good on it as well. So
Okay. And last question for now, is schema conversion tool supported?
no, it is not. Yeah, we don't have support for the schema conversion tool. If there are many tools with similar name, if my memory is correct, the schema conversion tool basically helps you to is a AWS service that helps you to see like, hey, we're going from a Postgres and we're going to a MySQL, let's say, and it will help you to do everything to converge one from the other. This is not something we support, and I don't think it is on our roadmap at the moment, but yeah, who knows?
Okay. Great. Well, thank you, Matthew. That was a great presentation. Very, very cool stuff.
Thank you,
Looking
Ryan.
forward to seeing how this keeps getting better.
Okay, thank you, Ryan.
All right. Next up on, let's see, we're going to invite Bart to the screen. Hello, Bart. I'm going to let you take it away. Tell us more about Cloud Pods.
Yeah, absolutely. Thanks, Brian. So thanks everybody for your time today. What I want to talk to you about is slightly different to what Matthew was talking about, but it's also one of the very cool services that we think that will help you accelerate your development. As a default, LocalStack is something that we think as ephemeral environment, but we hear more and more from our users and customers that they would like to see some level of persistence within the LocalStack. And we currently do that in two ways, and they're very unique use cases separately. First one is persistence, which allows you to locally enable, again, similarly like DMS, you can enable locally already, and it allows you to keep the state of your local infrastructure. And when you restart your container, it will come back to the same well-known state. In this setup, most of the services are already supported. So let's say if you created SQS, S3, and you want to pause your work, come back another day, and continue on that, persistent is one of those features that you can use. And the other option we've recently enabled and enhanced is called Cloud Pods. And this is what we're going to talk a little bit more about today. It allows you to take a point-in-time snapshot of the application and the infrastructure state together. And we're going to do a quick demo as well to showcase how that works. But effectively, you can restore your state of your application to a known state within seconds rather than minutes or multiple minutes in some cases. So how does it work? So we've got two options, like you mentioned, the persistence and Cloud Pods. Cloud Pods allow you to save and manage snapshot of your LocalStack instance. You can also use it to share the state and debug your applications collectively as a team. All the Cloud Pods that you saved within LocalStack are saved to our backend storage and you're allowed to share them with your team and make them public or private, depending on how you work on them. They also can be used to automate your testing in pipelines by preceding CI environments. We've got GitHub Actions and other options that allow you to automatically load Cloud Pods, whether from GitHub or from your local environment. And they create reproducible development and testing environments locally. So how would that look like? Let's say you wanted to create the S3 bucket, SQSQ, using these simple commands. At the end, you can save your pod and then restore it at a later date. And again, if you work within a team environment where you often work collaboratively on multiple features together, you can share the name of the pod and you'll be able to share that pod with your colleagues. So one way to manage pods was from the CLI, as you saw. The other way, also through our web application, you'll be able to see all of the pods that you save. And for those that are looking carefully, you also notice that we support versioning. So obviously, your infrastructure, your application will evolve over time, and we allow you to save multiple versions in response to changes to your infrastructure and application, as well as changes to LocalStack supported services. So what does versioning mean? Like I mentioned, you can save the version state of your application, and it will save state of services, data, and LocalStack version. Again, it allows you to add or remove services as application changes. You can see the history of changes as your services expanded or were changed. And also this allows us to ensure that as the new releases of LocalStack come through with new services and new capabilities, we continue to provide support and compatibility across these versions. And I will show you in a couple of minutes when we go to the demo section how the versioning looks like, what you can do with it, and what are some best practices around versioning as well. Something I briefly mentioned on, we can use Cloud Pods in your CI pipelines, again, to precede your infrastructure state and application state on your workflows. So to do that, on your environment, you will set up autoload pod command, and that allows you to load not one, but actually multiple Cloud Pods at the same time. And what that means is that you could divide your Cloud Pods into similar patterns as you would develop your application with. So you could have a backend Cloud Pod, front-end Cloud Pod, and also the database or data state. So again, couple of the benefits of using Cloud Pods over using maybe your infrastructure's code tools is that further cuts down on the deployment time from minutes to seconds. Restoring state from Cloud Pods, it's very, very fast, and we'll see that live in a moment. It can also be integrated in such a way that if your tests fail, we can save the state of the Cloud Pod at the end of the deployment and save that and share that with your team as well from your pipeline or from your local development. And that way you can also version your infrastructure state for integration end-to-end or acceptance tests. So you know which state of infrastructure you're testing, you know which LocalStack version you're testing, and which services you were testing. The other option that we've recently added, and I'll cover this one and one more right before we jump into the demo. At the moment, all the Cloud Pods are stored within our platform. We store them securely in S3, fully encrypted. But for these organizations and groups that do need their own backend storage, we now allow you to use your own remote storage to save the state of Cloud Pods. You can use S3 buckets on AWS or as compatible registries such as Docker Hub or any other ones that you may be using. So that way, not only you maintain the state of your Cloud Pods, but you also manage all the files and nothing gets stored directly in our platform. Now, there are some limitations because you won't get the full compatibility with our backend platform. But for these organizations that are more secure or consider state of the application proprietary, you may want to keep them in your own storage. Additionally, we have recently added pods end-to-end encryption. Cloud Pods are already encrypted by default with the SSE/S3 backend storage. So they're already natively encrypted in S3. However, we also allow you to use your own PGP keys or use a passphrase to encrypt and decrypt Cloud Pods. You can store the encrypted Cloud Pods on web app or remote storage options. Both of them are available. But if you were to use the encrypted Cloud Pods, you have to create new versions of Cloud Pods because you cannot combine encrypted and unencrypted versions of Cloud Pods. So that's one of the limitations that we do currently have. So I want to quickly jump into the demo and show you how that works on our sample application. So what we have is a service application that has a couple of standard services that you may have seen before, AWS API Gateway, that will handle our requests and forward them to one of the multiple Lambdas we're going to create. And we're going to have a DynamoDB that will store our data, and we're also going to be restored from Cloud Pod. Now, we also have a front end that I'm going to show you how that would look like. So in this case, we have 3 Cloud Pods I'm going to load. So in here, I already have LocalStack running. And we're going to run these side by one by one. And I'm going to show you how that changes both in the CLI itself here on our web app and what do we get when we go to the actual URL of the application. So first, I'm going to load the backend of the application. And as you see, we're going to quickly receive all the service in the Cloud Pod, iterate over the services that have been saved in that Cloud Pod, and load it up. So right away, you're going to see that we're loading Lambda, events, Cognito, CloudWatch, and a couple of other services. And now if I go to my browser real quick and show you the resource browser for LocalStack, you already will see that we have some services running. So API Gateway, CloudFormation, CloudWatch, and a couple of services that are required for these applications to work. And if I go back and now on the front end, we're going to restore more infrastructure to the same LocalStack instance. And we'll see here that we've got a couple extra services. And if I refresh here, that's also going to change. I can go to Lambdas. You will see I have all the Lambdas restored, fully functional IAM, and for instance, API gateway here, which already has all the endpoints created. So now if I go to this URL, web app S3, we'll see that all of our infrastructure has been restored. The front end is running. We can create a new node and we call it test node. And a save. That would just take a moment, and the test node has been created. But we have one more Cloud Pod to restore, and this is actually going to remove our entry because we are going to restore the database in addition to the front end and the back end of the application. So now if I refresh my app, you will see that this node has been preceded by a Cloud Pod. So what that shows us that not only the state of the infrastructure has been restored, but also the data can be stored and restored for preceding your databases. So that's one of the advantages of the Cloud Pods that we see, that you can really quickly restore your state of application, especially on things that are repeated and don't change very often. You can have that preceded in your CI on local environments for quick testing. So this was the first way to restore the Cloud Pods to your local instance of LocalStack. I'm going to quickly stop LocalStack and restart it, and I'll show you that we have no services running in just one moment when I go back to the web app to show you the other way in which we can actually load the Cloud Pods. So if I go back here now to my LocalStack instance, you will see that no services are currently running, no data has been restored. So I'm going to open the Cloud Pod that we were looking at earlier called backend. And at the same time, I'm going to show you a little bit about versioning and a few things that I mentioned. As you see, we've got currently 3 versions of this container, this Cloud Pod. And you will see that it was created by my colleague Harsh. It was created actually yesterday with LocalStack version 3.61 and with these services saved as a state for the Cloud Pod. If I look at the previous version, you will see that we added some services in here, that we've added logs and CloudWatch, and also that the version of the LocalStack that was created with is version 3.5.1, whereas the current version is on latest 3.6.1, and that's why we saw the change. So now from looking at the Cloud Pod here, we can actually load it into a default instance, which is the one running on my local machine. Or the other option that we can also do, and that's as a bonus, that's going to show us another service that we also recently released, that's called ephemeral instances. We can actually restore the state of this Cloud Pod into an environment that we manage and will be available for a short period of time for your tests. So as this is loading, in a moment in ephemeral instances, we should see, hopefully, that this has been loaded and we see a ephemeral instance of LocalStack created. So let's just give that a moment. As this loads, I can actually show you the other part of the application or the Cloud Pods. So if I look for notes, we have the front-end Cloud Pod as well, which in this case only has an S3, and similar way, it has the versioning, who was created by and when. And I'm hoping this has been started. Great. So as you see now, what we've created is an actual Cloud Pod loaded, but onto an ephemeral instance. So this is a new service that we've recently released as well, that allows you to use our backend platform, our SaaS platform, to create temporary instances of LocalStack, but running on our cloud. They offer the same capabilities as running locally and allows you to restore Cloud Pods. but can be easily integrated within CI, can be used as a preview for your environments and applications for end-to-end testing and acceptance testing, for instance. So this was the other way in which you can restore Cloud Pod and quickly test it and check whether it runs with the latest LocalStack version, whether it's compatible with your application, and so on. So if I go back to slides, this was our quick application. And also using Cloud Pods in ephemeral instances, which I was just showing you. You can inject the Cloud Pods into your ephemeral instance during the startup, or you can browse them just like I did, start from the Cloud Pod, and then load that into an ephemeral instance. Again, key benefits of this solution is the collaboration, like we did see previously with Cloud Pods in general. This extends that a bit further to allow you to create these ephemeral instances that you don't have to worry about configuration. We manage them, we instantiate them. You just need to worry about how long you need them for and which Cloud Pod you want to load. Again, often we see that there is use case for user and acceptance testing, and can further save you time and cost by unlocking your developers by having these instances available almost instantly, as you saw, within 30 to 40 seconds if it was ready and preceded with your infrastructure and application code. So a few things that I wanted to mention about some best practices for Cloud Pods that we saw over time. And we recommend at the moment for a couple of reasons. First, is to use pinned versions of LocalStack with Cloud Pods to ensure compatibility. Because of the frequent changes of Cloud Pods and also of the LocalStack itself, we can't guarantee at the moment compatibility between releases of LocalStack. So for instance, if you were using LocalStack 3.5, and as we just released version 3.6, the Cloud Pods may not be compatible right away with that version. We have some processes that we can share with you how to migrate your Cloud Pods from one version to another, but at the moment, there are challenges or potential challenges with migrating from version to version, but we can help you on the individual basis or share some of these best practices here. You can merge multiple Cloud Pods or import them to a instance of LocalStack. But one thing at the moment we don't have is ability to merge multiple Cloud Pods when the resources overlap between them. So if your Cloud Pod 1 has S3 and the second one has S3, that will be overwritten. We're now working on a feature that will allow you to do different types of merges: left merge, right merge, override, or import everything. And the other suggestion we have is for each version change to provide a description of the change to the Cloud Pod. So for instance, if I go back to my browser here, hopefully that will go back, and look at one of the Cloud Pods here that I previously created. If I look at this one, I'm mentioning in the description to that update to infrastate v2 with SQS. So it's useful for your version control and for state management to mention in the description what those changes would be between each version of the Cloud Pod. And that was the quick demo and a quick overview of the Cloud Pods. And I think we already have some questions lined up. And I think I may have covered some, but let's see. Ryan, over to you.
Yeah, we do have some questions. Actually, there's quite a few, so we'll get to them. So first up, are there any plans to prevent? You kind of spoke to this, but this is more, I guess, forward-looking. Like, do we have plans for solving the problem of breaking across different LocalStack versions?
Absolutely, we recognize this as a pain point. It's been raised to us already, and we actually are actively working on finding better ways to help you manage version changes. Obviously, there are some best practices that we can share and some GitHub Actions or some automations that we can share with you on how to automatically, based on changes to infrastructure, upgrade your Cloud Pods. So we can share that with you after the call on our Slack channel, or we'll send that out as well. I believe we already have that on our repo. So we'll be happy to share what we have now. But if there are certain aspects of that that you would like to see, please let us know. And we're gathering feedback right now for this feature to come through.
Great. Yeah, we should, we should definitely share those best practices. I think that would be useful. Obviously, it's a pain point, so it'd be great to get those out there. Yep. All right, cool. Can we store our Cloud Pods on our ECR repositories?
Not as far as I'm concerned, as far as I know right now, but that could be another option. We'll double check if we can get a question, who the question came from. I can come back on that and check with our team to see if it is. ECR is OCI compliant, so in theory it should be, but I need to check if that's something that we have enabled already.
Okay, sounds great. Okay. Is ephemeral instances available for starter tier? And is the pricing usage based?
Yes, it's available for starter teams and enterprise level accounts, and it is it's usage based. So you get the certain amount of credits per month depending on the tier in which you signed up to. So that's why we allow you to specify how long you would like the instance to run for. So obviously you consume them in the most effective way for your use case.
Okay. Excellent. All right. And then this is the final question. You kind of talked about it, and I obviously, well, we can't give specific date promises, but it sounds like this is something we're actively working on as well.
Yes, so this is close to being released. Again, like you said, I don't want to mention date specifically, that hasn't been defined, but it's not far from being completed, and eventually, and we should be releasing that, I believe, within this by the end of this quarter. So probably one of the next releases, you should see that coming up in the release notes. And yeah, at that point, you will be able to do different kind of merges and use different merge strategies for Cloud Pods.
Yeah, that would be awesome. Okay, so if we can get, versioning working and merges working, this is going to be amazing. I mean, it's already a really, really powerful tool. I mean, just to be able to kind of save this stuff and share it and load it up really quickly.
Absolutely.
I think that combined with ephemeral instances, as you showed, like just being able to say, hey, what does this look like? Let me just run it without even doing much work on my end. Just click the button and it's running. That is super cool. So I think it's already a super cool feature. To get those things in, it's going to be amazing. All right. So that's it for our questions. Great job, Bart. That was excellent.
Thank you.
I love the presentation. And I guess we will kind of go to the end here. So that's it for our presentations today. I really hope you enjoyed them. If you didn't get your question answered here, we've got multiple ways that you can communicate with the team. The best way probably would be to join our Slack and communicate with us via Slack. But we also welcome you to contact us via social media or our Discuss board as well. So we have lots of ways you can get in touch with us, and we love to hear from you. So we will. And I look forward to seeing you all next time we run these. And I'll see you next time. Bye.